Okay, so welcome back, and today we'll be looking at probability. So with me, I have a tutorial sheet full of questions on probability, and we are going to understand all the concepts under probability. Okay, so we're going to move from the basic probability concepts, like defining terms like the sample space, what are mutually exclusive events, independent events, and then from there, we'll talk about the probability rules, like the addition rule, multiplication rule, conditional probabilities, uh, things like that. Okay. We'll also look at how to get probabilities from the Venn diagrams. Okay. We'll look at the two-set problems, maybe three-set problems. How can we handle them? We also look at the tree diagrams. Okay, how can we get the conditional probabilities from the what? From the tree diagrams, the joint probabilities, and as well as the Bayes theorem applications. Okay, how can we deal with things like false positives, okay, false negatives, and the like. Okay, and then at the end, we'll look at the contiguous tables, which are just the two-way classification tables, right? And how to find conditional probabilities from those tables. So you can see all these questions here on probability. Okay, we are going to solve them, and they're going to help us understand. Okay, they're going to help us understand everything that is required for us to know under what? Under probability. So I hope by the end of the video, you will be able to what? To understand. Okay, so without wasting much of your time, let's start from question one there. All right, so question one, they're saying define the following terms as used in probability theory. Okay, so the first definition there, they're saying define the sample space of an experiment. Okay, define the sample space of an experiment. So the sample space is simply the set, okay, simply the set of all possible outcomes. Okay, all possible outcomes of an experiment. Okay, so this is what a sample space is. Okay, so for example, what is the sample space? Okay, if we say you're having an exam. So when you're having an exam, there's a probability that you either fail or you pass. So you can't do both. So the sample space there will be fail or pass. An easy example is when you toss a coin. Okay, so when you toss a coin, you are expected that the coin will land on its head or what? Or tail. So this here will be the sample space of tossing a coin. Okay, it's either you get head or you get what? You get tail. All right, so that's what the sample space is. And then let's look at mutually exclusive events. Okay, so they're saying define two mutually exclusive events. Okay, so we're going to say that events, okay, we're going to say events A and B, okay, are mutually exclusive, okay, are mutually exclusive if their intersection is empty. So meaning if you get event A and then you intersect it with event B, what you're going to get will be an empty set. So in short, there's nothing common between the set A, okay, and the set what? B. So two events A and B are mutually exclusive if their intersection is what? Empty. Simply meaning A intersection B is empty. So meaning there are no common outcomes between event A and event what? B. All right. Let's look at the third definition. So the third definition, they're saying we define two independent events A and B. Okay, so there we are going to say events A. Let me start writing by the word events. Okay, so events A and B, okay, are independent. Okay, I'm not going to write the full word. So events A and B are independent if, okay, the probability of A intersection B is the same as the probability of A, and then we multiply it by the probability of what? B. Okay, so if this situation holds here, we are going to say that these two events A and B are what? Mutually, they are independent, I mean, sorry, okay? We're going to say these events are what? Independent. Okay, so if you don't want to use this definition, we have an alternative definition, okay, to define independency. We're going to say two events, A and B, are independent, okay, if the probability of A given B is just the same as the probability of what? A. So we know that this here gives us the conditional probability. So if the conditional probability of A given B is equal to the probability of A, then we're going to say that the events A and B are what? Independent. Okay, so another form of this definition here, we're just going to say probability of B given A. Okay, so can we guess what would it be equal to? It will be equal to the probability of what? B. So if the probability of the event B given A is equal to the probability of the event B, okay, then we're going to say A and B are what? Are independent. Okay, we're going to say A and B are independent. So let's look at the last definition. So these definitions that we are defining here, we're going to be using them as we'll be solving questions, okay? I'll be telling you that you remember this definition, we use it here. All right, so let's define the fourth one, this one. So they're saying define the probability of an event A. Okay, so the probability of an event A is simply, okay, the measure, okay, simply the measure of the likelihood, okay, the likelihood that um, the event will occur. Okay, when you perform an experiment. So we can say when an experiment is performed. Okay, performed like this. Okay, so that's how we're going to define the probability of an event A. We're going to say it's simply a measure of the likelihood that the event will occur when an experiment is done, is performed. Okay, so in other terms, you can just simply say that the probability of an event A, okay, is the number of ways the event can occur, okay, and then you divide by the total number of possible outcomes. Okay, so the probability of an event A, okay, will simply be equals to the number of ways the event can occur, okay, and then divided by the what? The total um, number of possible outcomes. Okay. All right, so that's the definition there. And then we can now go to some questions where I'll be applying.
Okay, so let's solve part B. So part B, they're saying, suppose A and B are two events such as the probability of A is 0.6 and the probability of B is 0.7. Okay, and the probability of A union B is 0.9. Find the following probabilities. Okay, so the first one, we are finding the probability that we're finding the probability of A intersection B. So how can we find this? Okay, so we use the addition rule. So we know that if I'm finding the probability of A union B, then this is going to be the same as the probability of A plus the probability of B, and then minus the probability of A intersection what? B. So from the data that we've been given, we can see we have this given there. The probability of B is given, and the probability of A union B is also given. So we can just make this guy the subject of the formula. So I'll take this guy to the other side. So it will mean that the probability of A intersection B was simply going to be equals to probability of A plus probability of B, and then minus, if I take this to the other side, probability of A union what? B. Okay, so now here we're just going to actually replace with probabilities there. So probability of A is 0.6 plus the probability of B is 0.7 minus the probability of A union B, which is what? 0.9. Okay, so what is this? So you just simply punch that on your calculator. Okay, so it's going to give me 0.4. So the probability of A intersection B, I've found it to be 0.4. So here I can write 0.4. Okay, so that's the probability there. Okay, And then next, we find the probability of A complement. So that one is the easiest. We're just using the complement rule. So probability of A complement is going to be equals to 1 minus the probability of A. Okay, so what is the probability of A? Is 0.6. So the answer here also for the probability of A complement is just going to be 0.4. So I'm going to write it here, 0.4. Okay, we're done with that. We go to C. C, we're finding, the third part here, 3, we're finding the probability of A complement union B. Okay, so here, by the addition rule, this is the same as the probability of A complement plus the probability of B minus the probability of A complement intersection B. Okay, so the probability of A complement we have the 0.4 that we're just from finding. The probability of B has been given 0.7. So we only have to know the probability of A complement intersection B. Okay, so now here we're going to use an identity. So there I'm going to use this identity. I'm going to say, okay, notice that the probability of B is the same as, okay, probability of A intersection B, and then plus the probability of A complement intersection B. So in our given data, we have the probability of B, right? And then we also found the probability of A intersection B there, which is 0.4. So you can put the number here and put the number here and find this probability that we require there. But where is this formula coming from? Okay, so let's say, for example, we have two sets. This is the first set, set A, it has 1 and 2, okay? And then I have another set B, let's say it has 2 and 3. Okay, so if I was to draw this on a Venn diagram, it would be something like this. It would be set A and then set B, right? So this is set A and then set B. And then I have this box for my Venn diagram. Okay, so what is the intersection between these two sets? So it's just 2. So I'll put it there because 2 appears here and there. And then in A, I also have 1, and then in B, I also have 3. So it turns out that, okay, if I write this equation, if I write set B is the same as A intersection B, okay, and then plus B, plus A complement intersection B. Okay, so set B is equals to this, and it's true. So we can prove it from here. So B, we know what it is, right? It's this one. So let's see if, this A intersection B plus A complement intersection B is going to give me the set B. Okay, so B, we know it contains 2 and 3. So this is equals to, what is A? Okay, what is A intersection B? Okay, so A intersection B is just these 2 here. So I'll write the 2 as a set and then plus. I also have another set here. What is A complement intersection B? So A complement, it will be everything that is outside A here. Okay, so everything that is outside A is the A complement. And then I'm intersecting that with the set B. So the set B is just this guy now, this one here. Okay, maybe I've drawn lines outside. So the set B is this one, just this B here. So where can we see these red lines that represent the A complement, okay, crossing the blue lines of the B? We can see it's just this part here, starting from this part here, going all the way up to here. So inside this part here, that's where they are crossing. So it means A complement intersection B would just be these 3. So I'll write 3 there. Okay, so when I add this, what do I get? I still get my B, because that one is just going to be 2, 3, like this. Okay, so this equation is true. And then I'll just add the probability here in front. Even here, I add the probability. Even here, I add the probability. That's why I got this equation here. So that we've known where this equation is coming from, right? Okay, so since we've known where the equation is coming from, we can actually use it now to find the missing piece that we want to complete our question. Okay, so the probability of B is 0.7. And then this should be equals to the probability of A intersection B, which we found was 0.4, and then plus the probability of A complement intersection B. Okay, so we just make this the subject, or simply take this 0.4 to the other side. So it's 0.7 minus 0.4 is equals to the probability of A complement intersection B. Okay, so meaning the probability of A complement intersection B is equals to 0.7 minus 0.4, this is 0.3. Okay, so now we have whatever we need in order to calculate the probability of A complement union B. So here, the A complement is 0.4 plus the B is 0.7 and then minus 0.3. Okay, so what do I get? So I'm going to get what here? I'm going to get 0.8. Okay, because this is 0.4 here. 0.7 minus 0.3, I get another 0.4. So this will just be 0.8. Okay, so the probability of A complement union B is 0.8. Okay, let's look at the last one. So that's the last one, we've already solved it. So this is 0.8. So here they are looking for the probability of A complement intersection B, which we already found here. So that is just 0.3. And we are done with the part what? Part B.
So here they're saying the probability that a hospital gets an award for its excellent recovery rate is 0.17. Okay, so we had a similar question like this one in test 2. Okay, so the video is already there on the website, and part of it is there on YouTube. Okay, so the probability of that the hospital gets an award for its excellent recovery rate is 0.17. The probability that it gets an award for its cleanliness is 0.23, and the probability that it gets both is 0.12. Okay, and then we have to find these probabilities here that have been listed. Okay, so first of all, okay, let's label these events here. So the event that the hospital gets the recovery uh, rate award is 0.17. So we're going to say that is the probability of A. Okay, 0.17 like that. And then the probability that they get an award for its cleanliness. Okay, so we're going to label that as the event B is equals to 0.23. And then the probability that they get for both the cleanliness and the excellent recovery rate will be A intersection B, which will be equals to 0.112. Okay, so from there now we can start answering the question. So the first one, they're saying find the probability that the hospital will get at least one of the two awards. Okay, so what does it mean to get at least one of the two awards? Okay, it's either you can get only the one for recovery rate, or you can get only the one for the cleanliness, or you can get both. That's what it means to at least. Okay, so the probability, okay, of at least one, okay, one award, it will be the same as the probability of to be the same as the probability of the union of these events here. Okay, because we are getting either, so it will be the same of probability of A union B, and we know this is just the total probability of the union of two events. So when we expand this, it will be the probability of A plus the probability of A, probability of A plus the probability of B, and then we say minus the probability of what? A intersection B. Okay, but we have all these values. So probability of A is 0.17 plus probability of B, okay, which is 0.23 minus probability of A intersection B, which is 0.12. So what will this give us? So 0.17 plus 0.23 minus 0.12. So this one, okay, it's going to give me 0.28 as the probability that the hospital will get at least one of the what? Two events. All right, let's move on to part 2. So part 2, what are they saying? Okay, so part 2, they're saying find the probability that the hospital will get only one award. Okay, so only one award, okay, means that if they get the award for A or for recovery, it means they won't get the award for the cleanliness. Okay, and then On the other way around, okay, it means that if they get the award for the cleanliness, okay, then they will not get the award for the what? For the recovery rate. So how do you represent that now as a probability? So probability of only one award is the same as the probability, okay, that the hospital gets the award for A intersection that they don't get the award for what? For B. So this is B complement, okay? Meaning that if they get the award for A, they won't get the award for B. Okay, and then we are going to add here the probability, okay, that they get the award B, okay, intersection that they don't get the award what? B. So probability that they only get one award is either they get A, they don't get B, or they get B, they don't get A. So we add those like that, okay? But these ones here, okay, these and this, we can simplify them there further. Okay, so if you go back to your Venn diagrams like this one, okay, so this is my A, and then this is my B, right? So here we are saying probability of A intersection B complement. So let's try to shade this part here, the A intersection B complement on this Venn diagram here. So first of all, I'm going to shade the part A in yellow, okay? So I've shaded the part A in yellow, and then this part is intersecting with the B complement. So the B complement is everything that is not in what? In B, okay? Everything that is not in B. So everything that is not in B, okay, it will be everywhere here, as long as it's not in B. So everything that is outside B like that. Okay, starting from that, going like this. All this is the complement of B. So where does this complement of B intersect the set A? Okay, or in other words, to make it simple, I'll say, where do the blue lines that are indicating B complement, okay, cross the yellow lines of the what? A. Okay, so we see that the part that where these two lines will intersect is this part that I'm tracing in white here like this. Okay, that part there is where you can see here. It's where you can see both blue and what? Yellow, and they're crossing. Because intersecting, it means the lines should meet, right? Okay, so that is the part there that has been indicated. So in what other way can we describe this part here that I've traced in white here? Okay, so we can see that this part in white is the same as, okay, it's the same as the set A, all of it, okay, and then I say minus C, this part here, which is the intersection of A and B. Okay, so this here, the probability of A intersection B complement is the same as the probability of A minus the probability of what? A intersection B, according to this Venn diagram. Okay, so we're going to replace this with this, and the same things happens if you try to shade this. We're just going to get probability of B, okay, minus probability of A intersection what? B. So that's how we're going to simplify these two expressions there. Okay, so let's write them now and find the probability. Okay, so this is going to be equals to probability of A minus probability of A intersection B plus probability of B minus probability of A intersection B. So this is the same as probability of A plus probability of B minus 2, because this and this are the same, probability of A intersection what? B. So what is left there is just to substitute the values. So I'll do it here is equals to probability of A is 0.17 plus 0.23 minus 2, 0.12. So what do we get here? Okay, so you punch on your calculator. Okay, you punch that on your calculator. All right, so what I'm getting is 0.16. So this is the probability that only of the two um, the hospital only gets one of the two awards. All right, so part three. Okay, so part three now they're saying find the probability the hospital will get none of the awards. Okay, so probability that the hospital will get none of the awards is simply the probability of A union B what? Complement. Okay, so here we're just going to use the complement rule. So this is the same as 1 minus the probability of A union B. Okay, so at first we calculated this probability. Okay, so this would be 1 minus C. Remember we calculated this probability. We said it was probability of A plus probability of B Okay, and then minus probability of A intersection what? B. That's what we said this union is. So probability of A plus probability of B minus 0.1 2 like that. So this will be 1 minus, okay, 0.28. So this will be equals to, okay, okay. So if you punch this on your calculator, I'm getting 0.72. So this will be the probability that none of the two awards, okay, are given to this hospital. All right, let's look at part 4. Okay, so part 4, they're saying find the probability that the hospital will get a recovery award given that it has gotten a cleanliness award. So this is conditional probability. Okay, so we're finding the probability that the hospital will get the recovery award. The recovery award is A, given that, okay, it has gotten a cleanliness award. So this one, when we expand it, is the same as probability of A intersecting B divided by the probability of what? B. So this will be equals to, okay, this will be equals to, um, we're just going to get the probability of A intersection B, which is 0.12, divided by the probability of B, which is 0.23. So we just punch this now onto the calculator. Okay, so we have 0.12 divided by 0.23. So I'm going to get 0.52174. Okay, I can end there. So that is the probability, okay, that the hospital will be given the recovery award, given that it had gotten the cleanest what award. So it's a conditional probability. So same applies to part 5. So part 5, they're saying find the probability that the hospital will get no cleanliness award, given that it has gotten a recovery what award. Okay, so here no cleanliness award means what? Means B complement. So because remember the cleanliness award, we said it was probability of what? B. So it means the probability of no cleanliness, it will be the probability of B what? Complement. So the probability of B complement given that it has gotten the recovery award. So what we are finding there is just the probability of B complement given that it has gotten the recovery award like that. Okay, so from there now, how are we going to calculate it? Okay, so we are going to say, okay, we're going to say this is the same as probability of, we intersect these two sets, A intersection B complement divided by probability of what? A. Okay, but the probability of A intersection B complement, okay, we said that is just the same as probability of A minus probability of A intersection B divided by the probability of A. So this is going to be equals to the probability of A is 0.17 minus the probability of A intersection B, which is 0.12 divided by the probability of A. Okay, so what do we find there? You consult your calculator, of course. So it will be, okay, it will be 0.17 minus 0.12 and then divided by 0.17. So I'm going to get 0.29412. Can end there. Okay, so that is the probability. Okay, that is the probability that no cleanliness award, okay, will be given, given that the hospital already got the recovery award. Okay, so that was question 1. Okay, so thank you so much for watching this video. If you'd like to access full solutions to that paper, you can subscribe and access them at discretelearning.com. Again, if you're having challenges with your pre-med or your NS, okay, in any of these courses that I've listed here, biology, physics, chemistry, or math, okay, I would like to tell you about a platform that can be a solution to you. So that platform is discretelearning.com. Okay, so we have both the website and the mobile app, and these platforms have videos that can actually help you to better understand whatever you learn in class and just show you a simple way in which to answer questions. Okay, so you can subscribe and get help in any of these courses: biology, physics, chemistry, or mathematics. Okay, both semester 1 and semester 2. So for whatever course you register for here, you're going to access tutorial sheets, full videos for tutorial sheets. You're going to access full videos for assignments. You're going to access full videos for past quizzes, for past tests. Okay, you're going to access full video solutions to past mid-semester exam papers and also final exam papers. Plus, okay, you have an opportunity to consult from us. So maybe if you are watching one of our videos and you do not understand, you can simply inbox us to consult on that particular question. Then we'll be able to help you. Okay. And a bonus is that we also have live classes. Okay. So these live classes, we explain concepts to you on a live class. So meaning you're able to we're able to interact with you and you're able to ask questions there and then so that you understand the concept. Okay, and our videos are basically tailored to your university syllabus. Okay, so we are teaching what you need to know in order for you to actually pass and get to understand these things very easy. So I'm just going to show you that we have solutions to, for example, I'll say all the math tutorial sheets. Okay, it's the same in chemistry, the same in physics, the same in biology. So when you come here, math tutorial sheets, tutorial sheet 1 is on algebra. So all these questions here were solved in a very simplified way that you can understand. Okay, so all these questions here in tutorial sheet 1 were solved and the videos, they are available on the website. You can watch at your own time, at your own pace, even in your blankets. Okay, tutorial sheet 2 is on exponentials and logarithms. Again, we solved all these questions that you can see in this tutorial sheet too. And the videos are waiting for you on the website. Okay, so once you watch these videos, you understand the concepts clearly and you'll be able to answer questions in your assessments, like the quizzes, the tests, the mid-semester exam, even the final exam. Okay, there's also tutorial sheet 3 on functions. Again, we solved all these questions here. Okay, how to limit the domain, how to sketch the functions. We talk about the quadratic functions, um, and such things. Okay, all those questions have actually been solved. How to find the composite here. All these things we've solved. The videos are there available for you at any particular time. Okay, so that was tutorial sheet 3. Tutorial sheet 4 is on sequences and series. Again, we've solved all the questions in this tutorial sheet. Okay, all the questions here have been solved. They're there. You can access them on the website. Tutorial sheet 5, differentiation and integration. This is a topic that most students find difficulties with or challenges. Okay, we've solved. Okay, I've shown how you can differentiate in a very easy way. Okay, so how many questions did this tutorial sheet have on differentiation? It had how many questions? 5 questions. We've solved all of them and you can access them on the website. Tutorial sheet 6 is on descriptive statistics. Again, we've done justice to this tutorial sheet. We've explained all the concepts clearly and you can access them on the what? On the website. Okay, so all these questions have been solved. Tutorial sheet 7, which will be the last tutorial sheet on probability for semester 1, okay, has also been solved. So all these questions that you can see here have actually been solved and they're available on the website. Okay, so in addition to the tutorial sheet, guys, you get to access the past papers, the quizzes, the tests, the mid-semester exams, the final exam papers. You get to access them, okay? And also the topic lessons so that you understand the topics fully. They are all available on our website. So we also have this assignment 1 here. It was solved. Okay, so assignment 1 had like 2 questions. There's this one on pharmacokinetics. We solved it. And then question 2 is on exponential decay and growth, okay, of bacteria. We've solved all these questions here and they are available on the what? On the website. So if you need help in any of those courses that are actually listed here, biology, math, physics, chemistry, you can subscribe at discretelearning.com and you're going to access them. So you can contact me on these 2 numbers here, okay, if you want. Again, let me just show you the website for those who have never seen it. So you just go to Chrome here and then type in discretelearning.com. So you can see the discretelearning.com there and then go search. take you to our website. So here, if you don't have an account, you need to create an account. So you just go to start learning now. Okay, then it will take you to the login page. So if you don't have an account, go here, create an account, and then log in. But if you already have an account, just put your email, your password there, and then log in. Okay, after you log in, these are the things that you're going to see. So you can see mathematics, chemistry, physics, biology, everything that you need uh, to help you. So for example, I'll just use the math folder or the math course. If you open it, you go to your particular university. Okay, so if you're from Unilas semester, first semester, you go here. Unilas second semester, you go there. But if you're from any other university, you go in general mathematics. If you're from Apex, you use those. So I'll just use the semester ones here. So if I click on the semester one, you see that it's going to open and I'm going to have four folders: topic lessons, summarized, tutorial sheets, past quiz test, and exam paper. So if you go, for example, in the tutorial sheets there, okay, you're going to find videos for all the tutorial sheets. So you go to your intake. Okay, so the current intake now is 2026 January. I'll go in the 2026 January there. Okay, and you're going to see here the assignments are there and all the tutorial sheets are there, so you can learn and you can watch and learn from these videos at your own particular time. And if you have any question, you inbox us. Okay, so my number for those who want to register is 0779 96 40 10. So that is Tutor Pro Solutions. Okay, but if you just want to self-register, you can check the registration video guide in the description below here. It's going to show you how you can create an account on the website, how you can register, how you can pay and access these, okay, automatically without even needing any of my team members. All right, so thank you so much for watching. This has been Tutor Pro Solutions. Until next time, always there for you, and I wish you all the best in your exams.